The U.S. Army Corps of Engineers was dealt one of its biggest challenges as a result of the 1927 Mississippi River flood. The sense of urgency was great and led to the creation of the Waterways Experiment Station, now the U.S. Army Engineer Research and Development Center, to answer the call for flood protection along the Mississippi River. Since 1930, thousands of models have been constructed and tested by ERDC for many critical Corps projects. ERDC wrote the book on hydraulic engineering through its revolutionizing techniques and tools such as physical hydraulic models. One major success story is the Olmsted Lock and Dam model study.
And because of the total scope of this project, we had several scale models where we are investigating different aspects of the program. One of the major cost savings was our navigation model, where we came up with a configuration of the coffer cells that are used during the construction project. The beauty of the Olmsted project is the fact that all the model studies we did cost less than 0.5% of the project cost.
Research conducted by the Corps is not just cost-saving, but life-saving too. As the nation's premier builder of levees and other flood damage reduction structures, the Corps is committed to monitoring threats that could cause catastrophic levee failures. One sign that a levee might be compromised is the emergence of sand boils, which start when floodwater seeps under or through a levee, causing sand to boil up. ERDC researchers are developing an alternative to sandbags for the control and mitigation of sand boils during flood fights.
We came up with this idea of maybe using a filter, something lightweight that one person can take to the sand boil and maybe put it in that sand boil and control it. So this has been ongoing since 2016, and 2 years ago in 2017, we came up with the idea of let's make something to make sand boils in a controlled manner in a laboratory.
I mean, the effects are devastating. It's hard to even put a number on this. You're not only, of course, looking at life safety, which is paramount. That's our #1 priority, is life safety. But you're also looking at the agricultural lands, the livestock, people's homes, which we value as well, of course. And so it could be billions of dollars that could be saved with these new methods we're developing.
As the Corps Civil Works infrastructure surpasses its originally designed service life, material deterioration is an increasing concern. For many stakeholders, the need is great for cost-effective and environmentally viable solutions to repair, sustain, or replace infrastructure. The Corps found some solutions in materials that had already been developed for military applications.
The development and research in innovative materials for civil works and navigation structures has the potential for giving us the ability to do rapid repair, do repairs and remediation quicker. It gives us the opportunity to have new structures that are competitive on a first cost basis and have much longer lifetimes with reduced maintenance. So we save costs in many ways. This has been a very, very nice success story. The wicket gates they use at Peoria Lock and Dam and LaGrange are made from timber. They're white oak timbers that are very hard to source at this point. It was becoming very, very expensive to make these gates. They only have about a 15-year life in the river. But when we started to look at how we would do that with composites, we ended up having to reverse engineer the timber gates because we didn't have a design for those. We didn't know what the load conditions were and material properties. So we reverse engineered the timber gate, designed the composite gate to have the same weight, buoyancy, bending stiffness, strength capacities as the timber gates. So the financial benefit for the wicket gates, Rock Island District, in the first place, they're less money, so they're only 2/3 the cost to replace right out of the gate. They will last more than 3 times the timber gates, so they're going to require much less time putting them in. So you've got an upfront first cost savings. You've got a savings because they're going to last 2 or 3 times longer than the timber gates. And the savings that you get from that is not just the material costs, but also when they put these in the dam, it requires a maintenance crew, a dive crew, a crane and crane operator, and a floating plant for 3 days just to put in a few gates. So the savings over time is going to be tremendous, much more than just the $10 million material cost of the gates themselves.
Whether it's a new or existing infrastructure that the Corps constructs, operates, and maintains, there is a greater need for capabilities to continuously assess these structures during operations. Structural health monitoring curates accurate sensor and inspection data about the current and future ability of an asset or system of assets.
What we're trying to do in our research program is to connect the technology with the end user's need. And in this case, we need to prioritize our budget most efficiently. So we're aiming our structural technologies at providing that information that is necessary to help the decision makers prioritize the budgets most appropriately. And in that case, we're advancing the state of the art such that it can be used in the field, at the headquarters level, at the division level, to make those decisions that it's useful for. Several years ago, in the Northwest Division, the Dalles Lock and Dam was suspected of having some problems. The district engineers hired ERDC to put sensors on their structure, and they monitored these sensors very closely and made a decision to take their lock out of service several months ahead of when it was scheduled to be repaired. It was determined that this saved millions and millions of dollars of unscheduled outages and impacts to the economy. So we took a look at that success story about using sensors to prevent catastrophic failure to really build our concepts of what structural health monitoring could do. We looked at what made that a success, and we thought about how we can scale that up to be able to apply it to all districts without requiring them to spend countless hours reviewing data.
Another challenge facing the Corps is the navigation of aging waterways with newer ships. Engineers and ship pilots can now meet those challenges virtually by evaluating navigation channel designs, modifications, and safety issues using real data in a simulated environment.
The pilots from Port of Long Beach came in, as well as LA District engineers from the LA District. The first thing we tested were the Pier J turns. So you had to come into the breakwater, go around Pier J, turn left into Pier J. The turn they had designed was not wide enough. These large ships, they're 1,300 feet long, and they're 150 feet or more wide, and they kept running aground in our simulation. After a day of simulation, we sat down with engineers and with pilots, and we actually drew a larger radius turn into Pier J. Came back the very next day and tested those. The pilots were actually able to turn into Pier J successfully and to their mind comfortably, so safely. And by the end of the week, we had an alternative for Pier J and for the deeper channel that was feasible and fit within the district's BC ratio and that the pilots were comfortable using.
The ERDC ship simulator added significant value to our planning study. What the ship simulator showed was that the district proposed improvements were effective in navigating the next class of vehicles into the port complex. This is significant because we need to show that our proposed improvements are both technically and economically viable in order for the Corps of Engineers to proceed through the study.
This Civil Works application is now being used for military operations to get troops and equipment from ship to shore. As the Corps forges ahead in tackling the nation's toughest civil works challenges, it has not lost sight that solutions might lie in nature itself. The USACE Engineering with Nature initiative is fueling a new vision and approach for developing water infrastructure wherein natural and engineering processes are aligned to sustainably deliver economic, environmental, and social benefits.
And what we're doing with the program is finding ways in which we can use these past kind of exceptional examples to build and create momentum so that exceptional projects are more commonplace in the future. And it gives us a way to kind of evolve our program within USACE. USACE is a learning organization, so we're realizing that in the context of engineering with nature by drawing from our past experiences, combining that with the development of new technology, new engineering, and new science that is the purview of R&D, so that in the future that we can deliver the added value that can come from engineering with nature in important ways for our program within USACE.
The need for USACE to deliver the nation's civil works program has never been greater. We are committed to developing innovative and revolutionizing solutions to sustain and improve the design and management of the Corps' navigation, flood risk reduction, and environmental programs, adding value to the nation.